Hi, in this chapter we are going to talk about linked list, so let's get started. In a linked list, each node is composed of a data and a reference or a link to the next node in the sequence. It is very simple and very common data structure, and they can be used to implement several other common data types such as stacks or queues. The principal benefit of a linked list over a conventional array is that the list elements can easily be inserted or removed without reallocation or reorganization of the entire structure, because the data items need not be stored in memory or on disk in one block. We are going to see a quick illustration concerning this problem. An array has to be declared in the source code before compiling and running the program. It's very important that we have to compare array lists versus linked lists, because for example in Java we have the list interface, and both array list and linked list implement this interface, and we have to decide, the programmer has to decide that what data structure he or she is going to use. And that's why it is good to know the difference between arrays or array lists and linked lists. So an array has to be declared in the source code before compiling, and on the other hand linked lists are much more dynamic. On the other hand, simple linked lists by themselves do not allow random access to the data, and this is the main disadvantage of linked lists. So many basic operations such as obtaining the last node of the list, or finding a node that contains a given data, or locating the place where a new node should be inserted may require sequential scanning of most or all of the list elements as far as linked lists are concerned. So what's the problem? For example, here we just have I just want to summarize the time complexities for linked lists and arrays or array lists. And because the main advantage of arrays is that with the help of an index we can get an element in constant time, so order 1. With linked list we have to iterate through and go through the whole list in order to find a given node, which is going to yield linear time complexity. On the other hand, if you want to insert at the beginning, then linked lists are very convenient. We can do it in constant time complexity because we just have to update the references. As we have studied, the linked list consists of nodes and pointers pointing from a given node to another node. In an array, if we want to insert at the beginning, we have to reconstruct the whole data structure, and that's why it is going to be of linear time complexity. But arrays do not waste any space, and linked lists, because we have to store the references, it is going to be order n waste space time complexity. So use linked list if you want to insert or remove elements at the beginning. Use linked list if the size is changing frequently, otherwise use arrays. So as you may see, the linked lists are much more dynamic data structure. We can change the size whenever we want, but the size of the arrays have to be set at compile time, so we have to specify how many elements we want to store, so it is not so dynamic. But it depends on what kind of problem we want to solve with these kinds of data structures, and arrays have some advantages and some disadvantages, of course, and linked lists have some advantages. So use arrays if you need random access, because you can do it, it can be done very quickly in constant time complexity. So for example, what's the problem with array list? We have a list containing 1, 2, 3, 4, 5, 6, 7, 8 items. For example, we want to get rid of the 0. So we want to remove the 0 from the array. Okay, it's very easy, we just have to delete the 0. But the problem is that we have to reconstruct our data structure. We have to put each item and keep swapping these items until we have reconstruct the whole array. And that's why the time complexity for deleting, for example, an element from an array list is linear time complexity. It's very slow, not very slow, but it's not as fast as for linked lists. On the other hand, for example, linked list, we have 1, 2, 3, 4, 5 items, and in order to be able to detect the end of the list, the last node is pointing to a null. So if you want to remove, for example, the 1, we just have to delete it, and we just have to update the references. So the pointer from node 8 is going to point to node 6. So we just have to update the references, and it can be done very fast in constant time complexity. So for example, we see the illustration that removing an item is much faster for linked list than for array list. So if we have a problem when, or a software, for example, an application, and we want to use a list and we have to make a lot of item removal, it is advisable to use linked list over array list. So the advantages of linked list. Linked lists are dynamic data structures. Arrays are not, as we have discussed. It can allocate the needed memory in runtime. Very efficient if we want to manipulate the first element. It's very fast, constant time complexity, and it's very easy to implement. The linked list can store items with different sizes. It is a very important advantage. An array assumes every element to be exactly the same, and it is easier for a linked list to grow organically. An array size needs to be known ahead of time or recreated when it needs to grow. As we have, if we want to remove an item from an array, we have to recreate it. We just have to swap the items and reconstruct the whole array, or not the whole array, but most of the array. If, for example, if we remove the first item, then we have to reconstruct the whole array. On the other hand, the linked list it can grow organically without any problem. The disadvantages of linked list is that it wastes memory because of the references. Every node stores a reference to another node. That's why it's a linked list. And nodes in a linked list must be read in order from the beginning, as linked lists have a sequential access. Array items can be reached via indices in constant time complexity. So arrays, if we have an index, for example, if we want to get the 19th item, it can be done very fast as far as arrays are concerned. But in a linked list, we are not able to do it. We have to go sequentially through the whole list, and it can be done in linear time complexity. So difficulties arise in linked lists when it comes to reverse traversing. Singly linked lists are extremely difficult to navigate backwards. The solution, of course, may be the double linked list. It's easier to read, but memory is wasted in allocating space for a back pointer, and in this situation, for a double linked list, we have to store a reference to the next node, and we have to store a reference to the previous node, so it is not so memory friendly. On the other hand, arrays do not need any extra memory. So it depends, as you see, it depends what kind of problem you have. If you want to, you have a whole data set, for example, and you want to get the items with the help of indices, it is advisable to use arrays. If you have, for example, the problem that you have to manipulate and keep removing items from the given data structure, it is advisable to use linked lists. So for example, linked lists, we can insert items at the end of the list, and we can insert items at the beginning of the list. So for example, if we want to insert at the end, of course the first item is trivial. We just have to insert the 1 and it's going to point to a null. Why? Because with the help of this null we can decide that it is the end of our list. If we want to insert the 2, we have to go through sequentially and have to find the end of the list. And how can we decide whether it is the end, that it is going to point to a null? So 1, it's pointing to a null, so we keep inserting it. If we want to insert the 3, we have to go through the node 1, node 2, it is the last item, so we insert it. If we want to insert 0, we have to go through the whole list, 1, 2, 3, and 4. And we insert at the 4th position the value 0. So as you see, inserting at the end of the list have linear time complexity. So that's the conclusion. We have to iterate through the whole list to insert the new item. And that's why linked lists are usually implemented that we insert items at the beginning of the list. So we want to insert this 1. We insert it, it's quite straightforward. If we want to insert the 2, we don't have to go through the whole list. We just insert here and update the references. insert 3, we insert at the beginning and update the references. Update the references mean in this situation that we point the node we want to insert is store a reference to the next node, and we are going to point it to the previous first node, and that's all. For example, if we insert 2, for example, if we want to insert 2, then we update the reference that now the node 2 is going to point to node 1. Then here the node 3 is going to point to node 2. Insert 0, then 0 is going to point to node 3. So the time complexity for inserting item at the beginning is very fast. It is constant time complexity. So it depends on whether our linked list is we inserting item at the end or at the beginning. It can be slow or it can be fast. It depends on several things. So that's the main characteristics of array lists and linked lists. And of course, deleting from linked list is the same as for insertion. If we want to insert at the beginning, it can be done in constant time complexity, very fast. If we want to insert items at the end of the list, it has linear time complexity. So that's all about linked lists and array lists. Thanks for watching.